In this video, we will see how a moving vehicle can dynamically excite the bridge. To begin with, we have a simple 60-meter long bridge with steel eye girders and a concrete deck. It is 11-meter wide and we have defined a single lane at the center line which is 6-meter wide. We will be running an IRC truck 70R 7x2x2 at 3 different speeds to check the effect. Before we begin with the analysis, we'll quickly head over to the Loads tab and we'll make sure that we have imported the correct vehicle. In case you have not, the correct way to importing the vehicle is simply clicking on this small arrow and click on Import New Vehicle, select the region and select the vehicle which you need to import. Now the next step is to define the load pattern for our truck case. Now to do that, we'll simply head over to the Loads tab and under that we'll select the load pattern. We'll name a new load pattern as truck. We'll change the load type to vehicle live, click on Add New Load Pattern. Then we'll select the load pattern and click on Modify Bridge Live Load. In this menu, we will add the vehicle and their loading. You can see I selected the vehicle IRC 70R 7x2x2. The start distance and the start time will remain 0 and we'll set the speed to 25 meters per second. We'll click on Add. Then we'll assume the next vehicle will come 5 seconds after the first one and we'll change the speed to 50 meters per second. Click on Add. Then we'll assume the last vehicle, which is the third one, will come after 10 seconds of the first vehicle and with the speed of 70 meters per second. Once we are done with this, we'll change the duration of loading to 15 seconds and we'll change the discretization to 0.05. We'll press OK and OK to confirm the load pattern. Now the next step is to modify the truck case from static moving case to time history case to capture the dynamic effects. Now to do that, we'll head over to the Analysis tab. Under that, in the load cases, we'll select the truck load case which program has automatically defined. We'll click on Modify Show. And on the top right, you can see the load case type is now a multi-step static case. We'll click on this for the drop down menu and we'll select the time history. We'll keep the analysis type as linear and we'll keep the solution type as direct integration. Now you can see that program has a default load application called ramped, which we will not change. We'll change the output steps to 320 and we'll change the time step size to 0.05 and we'll press OK to confirm. Once we are done with that, we'll head over to the Run Analysis option and you can see that the truck case is a linear direct integration time history and the action is run. We'll click on Run now. Now once the analysis is complete, you have the log report in front of you which you can read and understand what all went in the analysis. We'll cancel this. Now we'll head over to the Home tab to check the deformed shape. To do that, under the display, we'll hover over to this option which says Show Deformed Shape. We'll click on that. We'll select the load case. We'll change the time as per our convenience. For example, at 2 seconds. We'll press OK. And you can see the deformed shape. And if you'll hover over, you can see the displacement also. Now let's see how we can plot the function for any specific point. First, we'll go over to this tab which says Show Undeformed Shape. Once we have the undeformed shape, we'll head over to the View tab. We have this option, Set Display Options. Under that, for the joints, we will uncheck the invisible and check the labels. We'll press OK. Once we are done with that, we can see the label of joints on our screen. We'll zoom in. We'll randomly select a point, say joint 159. We'll go to this option under the display, More, and we'll click on Show Plot Functions. And on the left hand side, you have the list of functions. You have also the joint which you selected, joint 159. We'll click on Add. We'll remove joint 158 simply while selecting the joint and clicking on Remove. Now once we are done with that, we'll select this option which says Define Plot Functions. Then we'll select the joint 159 and we'll click on Modify Show Plot Function. Now you can check any of these options for the vector type and any of these options for the component. For the vector type, we'll go with the displacement and for the component, we'll select UZ. We'll press OK and OK to confirm and finally we'll click on display to see the plot function on the screen. You can see on the right hand side it says joint 159, displacement UZ and you have the minimum and the maximum values. Now let's create a small animation video to study the dynamic effect of the loading. Now to do that, we'll simply head over to the File tab. Under that, we have a picture option under which we'll select the Create Multi-Step Animation Video. The program will ask you to save the video. Then we'll select the load case, we'll select the end time, we'll set the magnification factor for vehicles, we'll check the show vehicle tab, and we'll press on OK. Now you can see as the first truck passes, the effect on the bridge is minimal. Now as the second truck passes at a speed of 50 meters per second, you can see that the effect is slightly greater than the first one. And finally, when the third truck passes, you can see that the effect is much greater than the first two. This concludes the video, and this is how we can study the dynamic effect of a moving load in CSi Bridge.